Good afternoon, everyone. So, today I'm going to discuss one of the five factors of plant layout, which is man. As an element of production, man is more flexible than either material or machinery. You can move him around, divide and apportion his work, train him for new operations, and generally fit him into almost any layout that meets the operations and sequences wanted. For this reason, too many layout men and too many management men, for that matter, still continue to shove operations around. No one likes to be shoved around in some new layouts. This practice must lead to outright sabotage and many other, to resentment and lack of interest. After all, a relayout of his plant or department may be the biggest methods improvement in the life of a worker. The worker must be considered as well as the called economies of cost and reduction. Here are the features of demand factor demand involved include direct labor operators, group leaders and stewards, supervisors and foremen, line executives, indirect or supporting activity personnel, setup men, material handlers or stackmen, storekeepers, crib attendants, shop planners, dispatcher, expeditors, counters, timekeepers, process technicians or engineers, inspectors or quality control checkers, maintenance men, janitors, cleaners, receiving clerks, shipping clerks, plant protection personnel guards, firemen, tool making, conditioning, and machine repair people, attendants for auxiliary service equipment, power plant, etc., trainees and instructors, food disbursing personnel, first aid attendant, employment office personnel, staff or supporting activity executives, general office personnel. There are some considerations under demand factor. These are: first is safety and working conditions, second is manpower requirement, types of workers, number required, and operating hours. The third is man utilization, and lastly, other considerations. Safety and working conditions. The safety of workers and other personnel must be considered in every layout. Specific safety items that should be covered are floor free of obstructions and not slippery workers not located too near moving parts, unguarded equipment, and other hazardous workers not located under or above hazard workers not required to use special safety devices or guard. Adequate exits and clear escapeways, first aid facilities and fire extinguishers nearby, new sharp, moving or hazardous material or equipment protruding into aisles or work areas, all safety codes and regulations satisfied. The conscious shoes plant layout man cannot pass off problems of safety, congestion, and housekeeping as solely a foreman's responsibility. Lack of adequate aisles and storage areas and many other conditions are beyond the control of the foreman. They must be provided when the layout is planned. Working conditions. The layout should be comfortable for the workers. This involves heat, light, ventilation, noise, and vibration. These are related to the building factor, and we shall discuss them there. Modern heating, ventilating, and air conditioning equipment not only make working conditions more comfortable, but frequently allow better utilization of space. With overall air conditioning, layout man can locate operations from the standpoint of layout economy only and rely on the air conditioning to overcome any problems like furnace heat or exhaust fumes. Manpower requirements. Type of workers required, division of work, or specialization of labor is a basic fundamental of inexpensive manufacture. It reaches its ultimate in line production, fixed position layout. On the other hand, usually calls for a knowledge of many operations and for greater skill. So this figure 520, it illustrates the effect of layout on safety. It is an accident breeding congestion is one of the most frequent results of poorly planned layout. In figure 521A, this machine layout forces operators to move in the shaded area where handling equipment normally operates, with revision of workstation layout shown. And this, in the other hand, in figure 521B, congestion is relieved and the operator does not normally move into the aisle. Here's some saying of space is sacrificed for safety. So there are 4 manpower requirements. First is fixed position, fixed man. Second is fixed position, moving man. Third is process layout, fixed man. And lastly is line production, fixed man. In fixed position, fixed man, little or no specialization of work and high skill required. In fixed position, moving man, skill usually less, varying with degree of dividing the work and moving the man. In process layout fixed man, specialization by type of process, which is operation. And lastly, line production fixed man, it is a specialization by product and by operation. Picking out the right skills and getting workers with the right job classification is part of the job of manpower selection. Because wage rates and job classifications may limit the layout man's opportunity to reassign men to different operations or work areas. He must establish the manpower needed in terms of the various skills, trades, or classifications. The number of workers required as well as the type is frequently listed right in the operations list or routing sheet. In other cases, it is better to work by departments or work areas, determining the number of operators for each machine and the number of machines a man can tend. Here we rely on records of past performance, time data, or experience, just as in calculating the number of machines required. We begin with the quantities of production anticipated. This quantity multiplied by the time per piece gives the man time needed for the quantity. For example, 10,000 pieces per month times 0.20 man-hour per piece is equals to 2,000 man-hour per month. If we operate one 8-hour shift 22 days a month, we shall need 22 days times 8 hours per day is equals to 176 hours per month. So 2,000 man-hour per month divided by 176 hours per month is equals to 11.4 or 12 men. Here are some of the additional layout problems caused by operationing irregular shifts. Storage space and or special handling of materials is required on either side of the area operating the extra shift. Heat, light, ventilation, and other services will be required at one area and not at others. Special arrangements will have to be made of the facilities for all supporting activities, tool cribs, waste and scrap removal, inspection stations, elevators, separators, and the like. Special maintenance provisions will be needed where regular planned maintenance is interrupted. Special access must be planned to areas that are normally closed at night, offices, first aid rooms, cafeterias, etc. Special provision will be needed to intermittent handling or for a material not following regular paths of flow. Many companies have hope for expansion of capacity by the utilization of second and third shifts. The service facilities, however, were set up to accommodate production in one shift and hence become hopelessly overcrowded when multi-shift operation is undertaken. This is particularly true of receiving, shipping, raw material storage, and finished goods warehousing. While this situation may be blamed on management decisions after the layout was planned, the layout engineer cannot be short-sighted. He should point out such limitations to management beforehand, giving them the opportunity to change their thinking. Man utilization. Good workplace layout is based on the principles of motion study. Every man charged with workplace layout should be familiar with these principles. For a review of the principles of motion study, refer to Appendix X. The best way to improve individual workplace layouts is to apply these principles together with the man-machine chart or with the right and left-hand operator chart. To use these principles and charts effectively, we shall need first, the time required for various elements or motions, and second, the dimensions of the workplace. This is the addition to the dimensions of the materials and machinery which we should already have. In the next slide, you can see the figure 5-2 that shows how to apply these times to help evaluate planned workplace layouts. Different operations in different industries call for workplaces of different dimensions. For this reason, normal dimensions of man himself are important. These have been translated into usable industrial dimensions. So this is figure 5-2. It shows how predetermined motion times can help evaluate workplace layout. Here is a simple bench operation. Material container is a motion economy lip dispenser. Disposal point is a job chute. Motions of the fixture itself are not shown as they are the same in all three cases. So in the first table, it is a material dispenser's outside area of normal vision. In the table B, it is in disposal points outside area of normal vision but large enough to permit simultaneous releases. And lastly, in table C, it is an indisposal point in path of reach for material. The time required for various motion may come from time study. Some plans have standard elemental time data for operations that are repetitive. This gives satisfactory time values, but only to current methods and existing or similar products or material. For newly proposed methods or experimental setups or layouts, predetermined motion times are the greatest help yet discovered. These time data give the man time on any job. Layout men still have to get machine time by calculation or stopwatch time study. There are several sets of predetermined motion time data in use. Some are designed for one particular industry, others are universally applicable. The data and procedure are universally applicable. The data and procedure that seems to be most commonly used is methods time measurement. This table is the recommended workplace layout dimensions. As you can see in this table, you can see the bench work sitting inches, bench work alternate stand and sit on high stool inches, and work area standing inches. So there are three abbreviations, which is the S, E, and P. So S for the radius from top of shoulder, shoulder assumed to be 6 inches from edge of bench. E is for the radius upward from elbow, elbow assumed to be 6 inches from edge of bench. And lastly, P for depending on height of product work on. So here you can see the normal working area of hands in radius from shoulder 8 inches from spine. Maximum working area without undue fatigue for horizontal and vertical. Distance between workers center to center along workbench, excluding area for stock and spread out containers. Bench height top above floor for men and also for women, and chair seat above floor, foot pedal above floor, foot rest above floor for men and also for women, eye level height above floor for men and for women, and depth of shelves at eye level for men and for women. So these are the recommended workplace layout dimensions. These have been compiled from several industrial studies. They should be adequate for most industrial operations. They will vary from the value given according to the size of the product or machine. Women standing and wrapping packages averaging 10 inches high will want a workbench 28 inches high rather than 38 inches as shown. Basically, we are trying to avoid the need for long reaches and moves and unnecessary twisting and bending. These motions are time-consuming and fatiguing. Since all workers are different, these dimensions are only for persons of average size. Therefore, adjustable height chairs, benches, and footrest may go a long way toward individual worker comfort, especially where the operators at a given workplace may be of both sexes. Balanced operations. Forming and treating operations are balanced by using the procedures. Operations involving men and small tools are easier to balance. So there are 6 methods of getting balance for assembly operations. First is divide operations and apportion the elements. Second is combine operations and balance groups. Third is have operations move. Fourth is improve operations. Fifth is blank material and use lower operations and extra time. And lastly, improve operator performance. Divide operations and apportion the elements. This is the most common way of balancing assembly operations. Where the operations can be easily divided, it is possible to obtain a high degree of balance with little ideal time. Combine operations and balance groups. Many times it is not practical to divide an operation further. This holds especially on short lines. Here a group of 5 workers can be spread over 3 operations and alternated on the operations they cover. The ideal time of one operation is balanced against the ideal time of another without subdividing either. At least some of the workers will have to change places to cover 2 operations. Have operations move. Operations take relatively less time than the cycle balancing time. A worker may move with the work doing several operations. Sometimes he may even work in 2 different lines. Or he may go to a tight workstation and help out there. In small groups, workers with the light operations normally get the material handling work. When the operations take longer than the cycle or balancing time, balance can be obtained by having one worker move with the work through, say, 6 operations. If he moves back up the line and picks up each fourth unit, 4 men are balanced against 6 operations. In other cases, workers can be moved up to the head of the line at the beginning of each shift. They will get enough pieces started through the unbalanced operation for the shift. Then they will return to their regular place in the line.